This tutorial will help you to complete the questions on homework number 7. Let's take a look at the first topic here, 3 properties with algebraic expressions. So in this topic we're going to go over commutative properties, associative properties, and distributive properties. So they're going to ask you to identify which of those properties was used to get you from one line of work to the next line of work. So you notice that my first line of work has an 8 parentheses 10 plus 3x. My second line of work still has an 8 in parentheses, but the 10 and 3x have swapped places. That is a change of positions, also known as the commutative property. You'll notice there's 2 commutative properties listed here, and the property that you need has to match the operation in your sentence. So we have addition, so that's the commutative property of addition. Now, from line 2 to 3, the parentheses have disappeared, and new numbers have appeared here, 24 and 80. And that can only happen by distributing. So that is the distributive property. Let's try this one more time. From line 1 to line 2, again the 10 in the parentheses remain, so the 3 and 2x have swapped places. That's known as the commutative property of addition. In the third line, the 10 has been replaced with a 20x, and the parentheses have disappeared. All right, let's take a look at this third one. You'll notice the first quantity, x plus 2, remains the same, but the second quantity has changed the positions, and that's known as the commutative property. And then you'll notice that the 9x plus 1, the whole quantity, was swapped from the end position to the original first position, so that also is the commutative property. But this time, it's of multiplication, because the entire quantity has switched places. And the operation between them, between these parentheses, was multiplication. Okay. Line 1. The letters are N, M, O. And in line 2, it is still N, M, O. So no parts of these numbers have swapped places, so that is not commutative. But you noticed M and O are grouped together in line 1, but N and M are grouped together in line 2, so that's a change of grouping, also known as the associative property. Now, since all of these letters are being multiplied by each other, that's the associative property of multiplication. Now, from line 2 to 3, you'll notice that the group here, letters N and M, are still grouped together. They are still associated with each other. We've just swapped their positions or their order, and that is the commutative property. And since they're all multiplying each other, we choose commutative property of multiplication. Last one, let's take a look here. Quantity 10x plus 3. Second group, the quantity is 3 plus 10x. So the items within the group remain the same, just their order has swapped. So that's the commutative property of addition, because they are adding each other. And you'll notice in line 3 that the group went from 3 and 10x into 10x and 4x. So that one is a swap in the association, right? The associative property means I change the group from 10 and 3 to 10 and 4. All right, that concludes the first lesson. Let's go back and take a look at identifying properties in a different way. So when solving an equation, Emily's first step is shown below, and which property justifies the fact that she can turn this equation into a 1/3 x equals 1 into an x equals 3. So you have to think about the math that you're going to perform here, and the math that you're going to perform is to multiply both sides by 3, right? Multiply both sides by 3 results in a 1x equals 3. So when you're multiplying both sides, that's called a property of equality. Now we're not adding to both sides, we're multiplying to both sides. So I'm going to choose multiplication property of equality. Let's try this one more time. This time the parentheses are different, right? You have parentheses in the first equation, you do not in the second equation, and that is due to the fact that Emily distributed, right? 3 times x is 3x, 3 times minus 3 is minus 9. So that is the distributive property of multiplication over addition. All right, let's take a look at this one. 4, 4x3. 4, 4x3. So everybody's in the same position, so it is not a commutative property. You'll notice that the group was 4 and x, and now the group is 4 and 4, so that's a change in grouping or association. The association has changed, so the associative property was used here. One last problem. Again, same as the last one. 4, 1, x, 1. 4, 1, x, 1. So the order of all of the items is the same, therefore it is not a commutative property. And when we look here at the first two items, the grouping has changed from 1 and x to 4 and 1. So that is the associative property of addition, because addition is the property between these items. Okay, last one here. First equation, second equation. So the first equation had a plus 2, and the second equation does not. And the only way to remove a plus 2 is by subtracting 2 from both sides, and that is being written twice. So that is a property of equality, right? And because we are doing it on both sides, it is a subtraction property of equality. All right, let's take a look at the next level. Okay, let's see. 7x squared plus 10x squared plus 7 equals x squared plus 3. That's the original equation. And on the left-hand side, it looks like the parentheses have disappeared. The 7 remains, right? I have a 7 here, and I have a 7 here. But somehow these two items were combined together. And the only way you can do that is if you change this grouping here. So if I change the association here between 7x and 10x, I can group these two items instead so that I can combine like terms, right? So even though you want to say the property is combining like terms, that's not the name of a property, but you are allowed to combine like terms because you have grouped them together or changed their association, their associative property. So I use the associative property to group 7x squared and 10x squared, and that's why I'm able to add them together. Let's try another one. So it looks like I have 6x squared minus 3, and the items in the quantity remain the same. But this item outside of the quantity turned into a negative 3. So it went from a 6 to a negative 3. So it looks like I multiplied negative 1/2 and 6 together, even though they're not next to each other right now. So I would have had to move this item in the front here, right? I would have had to move this negative 1/2 timesing into the front in order to create that negative 3. When you move an item from one place to another, that is the commutative property. Right? So we're going to move that negative 1/2 in the front, and that will allow us to multiply it by 6. So the commutative property took place. Let's try one more. 5x squared and quantity 4x squared plus 9. It looks like these two were combined, and you can do that by altering the association. So that one is the associative property of addition, or the combining of like terms. Let's take a look at linear equations with distribution level 2. Now for most of you, you're not going to need any assistance here, but remember when you are distributing, if the number outside has a negative value, then you are using that negative sign to go with it. So that would be negative 10x. Negative 5 times minus 5 is positive 25. So be very careful with your signs when you are distributing here, and then when you're using your commutative or associative properties in your brain, right? Technically, you'd have to commute these terms to be side by side so that you could combine them. Technically, you'd be commuting these terms, but we allow you to just draw these loops and kind of take a shortcut. So negative 13x plus 20 equals 7. And then you'll be able to finish from here. Okay, values that make the equation true. This is the same as the topic before, but multiple choice questions. You're definitely going to need some scrap paper to do this. You should not be guessing and checking. You should not be substituting each of these values in to see which one works. You should be using your graphing calculator or your scientific calculator that has the ability to type fractions, and you should be multiplying 1/6 times x, and you should be multiplying 1/6 times minus 6/5. And if you're using a calculator, it will do all of that reducing for you, and you're going to get minus 1/5. And then when you add 1/5 to both sides, you don't have to find a common denominator because you're going to be using a graphing calculator, right? You should be using some calculator with a fraction function to do this math for you. So when you write your final answer here, and you are multiplying on both sides, select your answer and move along. All right, so you're going to distribute here. You're going to leave everybody else the same. This minus 1 in the front remains, only the negative 1/2 is being distributed. So half of 2 would be negative 1x, and half of minus 1 is positive 1/2, and then plus x over here. So I'm going to combine these terms over here. I've got negative 1x and positive x, so those cancel out. And I've got negative 1 and positive 1/2, so I've got 1/2 is equal to negative 1/2. Negative 1 and 1/2 can be combined. I'm going to multiply both sides by 2 over 1, right? Multiply both sides by 2 over 1, and I get x is equal to negative 1, right? X is equal to negative 1. So each time you're simply going to distribute, you're going to get some fraction, you'll use the fraction button on your calculator, and you'll get some good practice. Last one. Absolute value equations. When looking in your notes, you know that all math outside of the absolute value bars needs to be removed first. There is no math outside the absolute value bars, so we're simply going to take our quantity, and we're going to set it equal to our answer, right? But then we're going to do it again. This time, we're going to set it equal to the negative value of the answer. Because absolute value can be either in the positive direction or in the negative direction. So the steps are the same. You simply will get two solutions, right? So I'm going to subtract 3 from both of these values. But on this side, I'll get negative 15 is 3x. But on this side, I'm going to get 9 is equal to 3x. So our two answers are going to be 3 or negative 5. So both answers are correct. 3 is a possibility, or negative 5 is a possibility. So as we're typing them here, we're going to type 3, comma, and then it will open up a second space for us, negative 5. Again, look for any math in front or behind. Clear that math first, then take the exact quantity, write it twice. After the equal sign is where you'll make your modifications. One will have the exact answer, and one will have the negative answer. That's the only change you'll make. The math you'll do here will be the same for both. Subtract 14, subtract 14. Pick up your calculator if you need to. Negative 4x remains. Let's see, that's 6, 7, 8, 28, and negative 4x equals negative 56. So divide by negative 4, And sometimes you'll get an integer answer, and sometimes you'll get a fraction answer. So for us, we'll get -7 and +14. And we'll type that in. Again, putting a comma between the values. Okay, so last one. Again, write this quantity exactly how you see it 2 times. After the equal sign is where you'll change the value from a positive to a negative. And then you'll do your inverse operations. Subtract 5 from each side. Subtract 5 from each side. And then divide. All right, that concludes homework number 7.